Hey, today I have for you another animation effects using geometry nodes. The effect is inspired by old tutorial for Cinema4D created by A. Dyson. So, as always, switch to geometry nodes and let's pin that for this and let's create our base mesh. It will be triangle, so we want circle. It's easy, mesh circle, but with only 3 vertices with n-gon. We want rotate this from the bottom of triangle, so we must push this triangle to this axis, because now we rotate by the 0.000, and when we have transform, we rotate this by y, and it's not rotating as we want. To do that, we need to calculate the bounding box, and we want the minimum value separate, and use the x value to calculate absolute, and combine x, y, z to x vector transform, and we have our triangle on the y-axis. And now we can, with another transform, correctly rotate our triangle. But we don't use this one. As in previous example, as in previous tutorial, we use the empty to control our animation. So get our empty, subtract from our position, map, vector map. Okay, so we need more our triangles, and also we will be working on instances. So to do that, we copy our triangle a couple of times. So add point, maybe 5, and instance on points. Point instance, and here set instance rotation. Rotate instances. So here I rotate everyone, and here also I can rotate every as the same, but we want a different rotation for everyone, so we need to add some value to every triangle, and for that we use the index value and add this to position. But we also only want to rotate by y-axis, so combine. and put this on my. I'm going to use this, but I want to specify my count to outside. So now when I have my cube, I here can control how many triangles I want. Maybe 5. Control H to hide unused inputs. Maybe a little bit. Organize. Okay. So to better control our rotation, we need to arrange our rotation. So add map range. So here I add separate X, Y, Z because I only want the X value, and here I connect X to this. Rotating, and here I put another map range to calculate our rotation, and also add map to radians, and I want to maybe for now 90 degrees. Why I only have 2. We need our count to know how many is our triangles, and here we put our value. But exactly we want from 1 to last, but we have we need to map and subtract 1 from our count and put this here. To better visualize our triangles, I add extrude here. By little bit, and better. And as you see, we always have correct space. To go to our animation, I want to have this type, so minus 180. And here I have nice movement. For smoother, we can put smoother step, and it will be a little bit slower on start, faster here, and also slower at the end. To test this on bigger scale, we can add more points. So we grab these points and create some fast grid. So grid, instance, and here we must get realize instance and put this two here. Maybe a little bit bigger, and also maybe some more. Maybe not. Oh, a little bit bigger. Yeah, something like that. To correct our animation, because now it's working one by one. To correct our animation, we must calculate the modulo from our index. So now it's is 1 to 0 to 6, 0 to 5, 6 to 11, 12, and so on and so on. So, but we want to 0, 6, 0, 5, 0, 5, 0, 5. To do that, we use math and operation modulo. And here we grab our count of triangles. We can add a little bit more of it to better see. Yeah. And also we can add some noises to our line of animation, and to do that we add the noise to the position. So we add noise texture, and add here. It's also a little bit too small value because it's from 0 to 1, so we can multiply and add. Math here and for previous tests is the better way to use to subtract a half from the multiplication, because the multiplication provides this moving upward, but it also noises a little bit. So I add value and map multiply -1 -2. So it's not multiply but divide. And now we have a little bit more control of our noises. So when I put more, it noise up more and also less. So I like something like that. Yeah, it's nice. So, and also the last part is to build up hexagonal grid, and I use that from tutorial by Kaiterjan Carmel. To create our hexagonal grid, we need to create another circle with 6 vertices. Now this one, we want to see this. and we need to transform this, copy this on one axis and next to another. So first create mesh line and instance on point. These are our points, this is our instance, and in mathematical calculation 866. It's okay. And now we want to move the second one up a little bit. So to do that, get index and separate next one. So second and vector map multiply and set position and now position to offset, and we want to 1.5. To finish our grid, we need to instance this. So get this one, instance in point, instance, and move this by 3. And to control that, I get our count and Ctrl H to unhide, connect this to next one. With N we can get group and this name size, and also work with this, but it's not like rectangular, so we divide map and divide this by 2, 3. Maybe something like that. Yeah, it's nice. Okay, so to finish this, we need to realize instance, and now we have it. Also, to correctly view our triangles, we can switch type of fill to triangles, and now with the wireframe we see how our triangles must be rotated. So if I'm correctly, it's it's not this rotation. Yeah, so we need to rotate our triangles by 90 degrees. Transform. Here and here, and get and also we need to scale our triangles a little bit because it is too big. I think that's enough. So if it's working or not. Well, I think because we need to see this. We can also center our grid before our instance points of grid. We can calculate the position with attribute statistic. We want vector, get points, position, and subtract vector map, subtract minimum and maximum, divide by 2, and set position. And position offset. Yeah. And now it's always centered. Here our cube, our size, we have always be in center. To color our triangles, I separate the two halves. With Shift B we can focus on our selection, and we see here it's not closed mesh, so we join the geometry with our original mesh, but also we want to flip face to correct calculate normals, and merge by distance. To separate this, I also add one loop, so mesh subdivide, mesh, separate by geometry, faces, and we get position because we only want the z-axis, so separate x, y, z, and c compare greater than. I only did this, but I want a little bit more, not that much. Or yeah, maybe. Yeah, this one. So I open another panel with shader editor and add two materials. One for that. I have blue and another green. So this will be green and this will be blue. And here we can add material like this, select material here and also here, because this is inverted. This is the top, this is the bottom, and this is the top. And here we join geometry and also can add merge by distance. And here I blue and green. by accident. And also I have these empty spots, so to fill that I use my geometry and rotate this by 90 degrees. By Z, 180. Sorry. Add instance second time. Instance and so now I have this. Maybe I want all, so have no. I don't want this one. Instance. Merge like this. Yeah, that's much better. Okay. 180. And this will be opposite of this. So drawing geometry. Oh, because I have one of this, so I also want to have second one. Make this and this, but without rotation. We can also green 90, 180. Yeah. And better. No. Okay. And do this, and here I have this. Okay. And last thing, I push these triangles a little bit down, and so because they are yeah, and this blue we need to push down. So transfer geometry and maybe a little bit more, yeah. And also push this by line. And now I think it's working correctly. So we can get from pure green to full blue. So yeah, a little bit longer than previous tutorial, but I think that's all. If you enjoyed this content or found it in any way informative, please hit that like button and subscribe. Thanks for watching.